pOH is just like pH, in which it is a measure of the hydroxide ion concentration in moles per liter in aqueous solutions, which is calculated in a similar way. Knowing the equilibrium constant for water at 298 K, and therefore how pH and pOH total 14, it gives us another method for calculating pH of alkaline solutions or the pOH for acidic solutions. Just use algebra to solve for what you need. The trick is to determine the concentration of either hydrogen ions or hydroxide ions from what you're given. So, you're given 0.004 moles per liter of potassium hydroxide. Determine the pH. Since we know that potassium hydroxide is a strong base, it completely dissociates into its ions. Therefore, the concentration of hydroxide ions has to be 0.004 moles per liter. This can then be converted to pOH, and since we know that pH plus pOH equals 14, we solve for pH, which equals 11.6. Here's a slightly more difficult one. The pH of barium hydroxide is 10.5. What is the concentration of the solution? We know pH plus pOH equals 14, so we'll solve for pOH. Now we need to convert the pOH into the concentration of hydroxide ions. This value tells us how many hydroxide ions are floating in solution. Now since barium hydroxide is a strong base and yields 2 hydroxide ions per mole, we must halve this concentration because of the 2:1 ratio, as in 2 moles of hydroxide ions are produced per 1 mole of barium hydroxide. So there it is.